This lesson is going to look at ions and ionic compounds by using Bohr's models to illustrate ions and to show how ionic compounds are formed. Let's get started. Sodium is a group 1 element with an atomic number of 11, which means that it has 11 protons in its nucleus, and for a neutral atom, we have 11 electrons around the nucleus. The 11 positives are balanced out by the 11 negatives for an overall charge of 0. Now, this sodium atom, along with all other atoms, with the exception of hydrogen and helium, and we'll talk about those in a moment, want to have their outermost energy level containing 8 electrons. That's a full octet. The difference with hydrogen and helium is that they only have one energy level, and that first energy level holds a maximum of 2. So their full set would be 2 electrons. Sodium has 1 electron in its outermost energy level, or 1 valence electron. It would need to gain 7 more in order to have a full octet. That's a lot of energy spent gaining electrons. But if it was to drop down to the energy level right below it, it will have its full 8. So it's a lot easier, less energy spent for sodium to lose its valence electron and drop down to a full octet. When that occurs, we maintain the number of protons because it's sodium, and sodium always has 11 protons. To change the protons, we change the atom. But our number of electrons do change. It decreases by 1. And we see that we will have 1 more proton than electron, giving us an overall positive charge. The difference between these two is that this sodium is a neutral atom, whereas this sodium is a positively charged ion. Now let's look at chlorine. Chlorine is in group 17 and has an atomic number of 17, which gives us 17 protons in the nucleus. And in order for this to be a neutral atom, we have 17 electrons to balance out that charge to give us a 0. Now, looking at our valence electrons for chlorine, we see that we have 7 valence electrons in its outermost shell. It wants 8. It only has to gain 1 more. And when it does that, our number of protons is going to remain the same because we're still dealing with chlorine, but we're going to increase our number of electrons by 1. And when we do this math, we see that we have 1 additional negative charge electron, which is going to give us a chloride ion. Sodium, being a positive ion, is known as a cation. And chloride, notice I changed the ending, being a negative ion, is known as an anion. Now that we've illustrated how ions form, let's talk about ionic compounds. Sodium is more than happy to donate its 1 electron to chlorine, who is very happy to accept it. And when this occurs, sodium will drop down to that lower level containing a full octet, forming an ion. And to indicate that this is an ion, we actually add brackets around the model and the ionic charge, the oxidation number, as a superscript at the top. Chlorine, which gains the electron from the sodium, will form an ion, and that is indicated with the brackets but a negative charge outside. These 2 ions are held together by an electrostatic force, which is an attraction between these 2 oppositely charged particles. This forms your ionic bond, and the entire thing is known as the ionic compound. And this is our first example of an ionic compound called sodium chloride, whose chemical formula is NaCl. We will get more into chemical formulas and naming ionic compounds in a later lesson. Now on to our second example. Magnesium is a group 2 element with an atomic number of 12. This means for the neutral atom, it has 12 protons and 12 electrons to balance out the charge, giving it an overall negative charge. its outermost energy level contains 2 valence electrons. Remembering that it wants that magic number of 8, it would need to gain 6 more. It's much easier for magnesium to lose the 2, drop down to the lower, than to gain 6. And like sodium, when this occurs, a number of protons will remain the same, but the number of electrons will change, decreasing by 2. And when we do that math, we're going to have 2 additional positive charges. And when we write this ionic symbol, it's going to be the chemical symbol with the superscript of 2 positive. And because we have more than 1, we definitely need to write that number there so we understand how many charges we have. I wanted to pause here to bring your attention to the fact that both sodium and magnesium, both are metals, lost their valence electrons in order to drop down to their full energy level right below. So metals lose electrons to form positive ions. For our second element, we're going to stick with chlorine, but I want to point out that all nonmetals gain electrons to form a negative ion. It's easier for them to gain the few to get to form a full octet of 8 than it is to lose many. Okay, looking at our Bohr's models for the neutral atoms side by side, can you tell where the magnesium would want to transfer electrons or donate electrons to chlorine and where chlorine will want to accept them? We have 1 electron from magnesium that will happily be donated and happily received from the chlorine. However, while chlorine is happy, magnesium is not. So in this case, we will add another chlorine. The 1 remaining electron that magnesium wants to donate, another chlorine will happily accept it. And when this occurs, we're following the same process we did with sodium chloride, whereas we write our magnesium ion with the brackets around it showing the 2 positive charge at the top, and then we'll bring our chlorine ions down on either side with the brackets and the charge. This is your Bohr's model illustration for this ionic compound, where the space in between is the attractive force that's holding them together, or the ionic bond, and the entire thing is the ionic compound. And notice what happens with the overall charge for the ionic compound. Our 2 positive charge for magnesium is balanced off with each of the negative charges for the chlorine, and that's going to give us an overall charge of 0. This compound is known as magnesium chloride. And our chemical symbol for this one is 1 magnesium for every 2 chlorines. In summary, metals lose electrons and form cations, which are positively charged ions. Nonmetals gain electrons and form anions, which are negatively charged ions. Electrons are transferred from metal to nonmetal. And the overall charge of an ionic compound must equal 0. These examples should help you complete the other activities in this unit. If you have any questions, don't hesitate to reach out to me.